All right, so here's prerequisite 5, transformations of y equals square root of x. It shouldn't be hard. I mean, we've been doing this stuff. We've been memorizing them in class, and we've been learning forms, so we ought to be pretty good at this. So, if you forgot, let's make a table. We have x, and the output's going to be the square root of x. Okay, we call that y, but it's the output. And the smallest number that you can take the square root of and be real is 0, and the square root of 0 is 0. The second smallest number you can take the square root of is 1, and the square root of 1 is 1. And the third smallest number you can take the square root of is 4, and the square root of 4 would be 2. Now, if you wanted another point here, you could do like 9. Square root of 9 is 3. But 3 points is enough. So 0, 0's on the graph, 1, 1's on the graph, 4, 2's on the graph. And like I said, if you wanted to, you could do 9, 3. Because some of you like to make this thing curve up. And it doesn't curve up. It doesn't go flat either, but it doesn't grow very fast. After 9, the next thing you can take the square root of is 16, which would be somewhere over here, and it's only 4. So it doesn't grow that fast. All right, domain. The low x value is 0, and then it runs forever all the way to infinity and beyond, as Buzz Lightyear would say. The low y value is also 0, and then it rises, albeit much slower, on its way to infinity. If you have become a set builder kid and you like set builder, all values of x such that x is greater than or equal to 0. And if you are, for range, all values of y such that y is greater than or equal to 0. Got to know them both. I feel like that camera's not turned quite right. Let's do that. All right. Vertex form for y equals a times x minus h to the 1/2. Now, when I type, it's a lot easier for me to use exponents, so don't be alarmed by that. They're the same thing. The square root of x is the same as x to the 1/2. The 1/2 power means square root. Second root's what it actually means. All right, so what are these things? All right, well, they're still the same things they have been. A is still, guess what A is? It's the initial slope. That isn't going to change. Now, a arm, which is what we call the square root function, doesn't have a center. But hk is the first point. There we go. First point on the graph. Not a vertex. We don't have a vertex. And everything else stays the same. If a is a number stuck between 0 and 1 like a half, then the graph is vertically compressed. That hasn't changed. If a is bigger than 1, then the graph is vertically stretched. If a is negative, the graph is vertically reflected. None of that has changed. Okay? It's all the same, except for this, because we don't have a vertex. All right, identify the transformations in the equation f of x equals -2, parentheses x minus 3 to the 1/2. And again, note the 1/2, that's the same as -2 square roots of x minus 3 plus 2. So we're just going to line up with our form, a square roots of x minus 3 plus 2. And I don't know why I wrote x minus 3 plus 2. I should have wrote minus h plus k. So I see that a is -2. Let me type that as opposed to writing it. So I see that a is -2. All right, so talk about that. Since a is negative, there's a vertical reflection. The absolute value of -2 is 2. This tells me that there is a vertical stretch. If I do my lineup process here with h, I see that h is 3, and h literally stands for horizontal. There's a horizontal, let's use a big word, translation, right 3. I see k, if I do a lineup process here, is 2, which means there is a vertical translation up 3. There's your transformations. Like, that's how hard transformations are to pick out. They're not hard. All right, g of x is a transformation of f of x being the square root of x. Identify the transformations. Graph f of x and g of x. I'm actually going to start with graphing first. So here's mama. Here's your f of x function. And that way I can see the transformations. Now, g of x has an initial slope of -2. And we have a point on the graph at -1, -3. And I don't need to modify these. It's not a vertex, but this will be the first point. And it's at -1, -3. And then let's go with it. All right? So we're going to fall back. And by the way, -1 because I changed sign, -3 because I keep sign. Fall back 1 and then down 3. And my initial slope is -2, so I fall 2 units and I run 1. And 2 points is enough. Okay, I didn't need 3 points. Could have done it. If I wanted a third point, it's a little harder to do, but I would have had to take this forward 2 point. I'd have multiplied it by -2. That would have got me down to here, and then I would have fallen 3 more. And then I would have shifted it back 1. Which I will teach how to do that kind of stuff later, but that is a little too much for the beginning. Alright, so the transformations that happened here, obviously if you look at this thing, there was a vertical reflection. It was shifted left 1, it was shifted down 3, and what else are we missing? It was stretched. There was a vertical stretch. It's taller, right? Yeah, that's the idea here. Domain and range be now. This one's different. This one is different. The domain here, we shifted left 1. And then we run rightwards to infinity. The range, it actually rises from infinity, and it stops at -3. There you go. Easy peasy lemon squeezy. Alright, g of x is a transformation of f of x being the square root of x. Identify the transformations, blah, 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 same old thing. So, square root of x again. Let's draw mama first. Mama looks like that. And there is square root of x. Let's talk about our first point here. We are left 4 and down 3. Sorry, not left, right 4 and down 3. It's going to put me about right here. And my initial slope is 1/2. And what does this mean? It means rise 1/2 and run 1. So I'm only going to rise 1/2 a unit, and I'm going to run 1 unit. This thing is not as steep as mama. That's the idea. It's not as steep. So what transformations happen? Obviously there's a shifting. It's not in the same spot, right? Obviously. It was shifted right 4 and it fell 3. So right 4, down 3. That's a transformation. It has been compressed. There is a vertical compression. Alright, domain. She was shifted right 4 and she doesn't go past that point right there, so 4 to infinity. The range would be -3 to infinity. There you go, boys and girls. We got 2 left to go. Now this one's going to be a little harder, okay? This one's where we're going to have to factor and find out. So let's rewrite this so it looks like a square root symbol. Now, 4x and 16 are both divisible by 4. So, let's put a 4 there. If I divide a 4x by 4, I have an x. If I divide a 16 by 4, I have a 4. And, you know, what is the square root of 4, right? What is that thing? You know, some kids don't know. It's 2. It's always been 2, and it always will be 2. So, we get an equation that looks like this, because we evaluate that piece. And now I can identify things. I can identify not the vertex, but the first point on the graph. I really need to change all these notes. Bummer, found something I need to do. First point on the graph. So the first point on the graph here would be -4, -6. Remember, change, keep. the initial slope, which for some reason is missing from this side, is equal to -2. Hopefully this is the last one in these notes. All right, here's Mama 001142. Graph the kid. Kid's first point is at -4, -6. And the kid has an initial slope of -2. Follow 2, run 1. And there's the kid. Now that kid's domain is to travel from -4 right to infinity. That kid's range is to rise from -6. Sorry, not rise from -6. Rise from -infinity to -6. And I want to do some set builder on these. I don't have the time for it, but it needs to be done. Or all values of x such that x is greater than or equal to -4. Down here, or all values of y such that y is less than or equal to -6. Now what transformations are present? If you look at the difference between the orange and blue function, I mean, you'll see them. It has been reflected. There is a vertical reflection. It has been stretched. Even though it's opening down, it's still taller, so there is a vertical stretch. And obviously, but it's been moved. It's been translated left 4 and down 6. And there's your 4 transformations. All right, last slide, then I probably need to get some homework. Oh, that is the last slide, so there you go. There is the p.5 lesson, transformations of square roots.